again, learning target 4 is verifying identities. And to verify an identity means they're going to give you an equation, and you're going to show that both sides are equal without actually using any properties of equality. So you aren't actually going to solve the equation. You aren't going to be moving things to each side or subtracting things or anything like that, or dividing things out. You're just going to rewrite one side or both sides to show that they're equivalent. Okay? That's what we're doing to verify. So we talked about a lot of tips you could use. We could transform the more complicated side. We could substitute identities to simplify expressions. We did that in learning target 3. If you see tangent, you change it to sine over cosine. We just are substituting things that we know are equivalent. We might need to factor or multiply to simplify expressions. Definitely you're going to have to FOIL on some of these. And some of the homework you might need to factor some things out in order to get it to work. Multiply expressions by an expression equal to 1. That's if you need a common denominator or something. And then you could, if you couldn't figure anything else out, express everything in terms of sine and cosine. So then at least everything's the same function. So like I said, don't try to solve equations. So don't try to divide out sine from each side, or don't try to subtract cosine from each side, or anything like that. If you're verifying them, you don't know that they are true. They all are going to be, but you are proving that they are true. All right? So you can only work with one side at a time. That's the most important part. Okay? All right. So first one. We have secant squared minus tangent x times cotangent x equals tangent squared. And I think we did this one last week before you guys left, but just to remind you, tangent x and cotangent x are reciprocals of each other. So if I rewrite one of those and then multiply those together, I have tangent x over tangent x. And so tangent x over tangent x is just 1. So I have secant squared x minus 1 equals tangent squared x so far. Okay. You have to start memorizing those identities, because in my mind I'm thinking of the Pythagorean identities, and I know that we already have one that says tangent squared x plus 1 equals secant squared x. Now this is a verified identity. That means that we know this is already true. It will always be true, and so we can rewrite this one if we need to. All right? So if I see this problem, I have a secant squared x and a tangent squared x already, and there's a 1, so it looks like it could be equivalent. I just need to rewrite it to make sure. So if I subtracted 1 from each side here, then anywhere I see secant squared x, I can replace it with tangent squared x. So now I've proven this is true. I've shown that both sides are exactly the same. Does that one make sense? Or do people have questions? Okay. Then on the next one, you have this messy fraction with sine and cosine. And then you have another side that has secant and cosecant. Okay? If I'm looking at this, I probably want to mess with the more complicated side, if I can. And if I'm looking at it, I see I've got a sine theta and a cosine theta in the numerator and the denominator. And it would be really nice if I can cancel those out. Now make sure you keep all of your algebra rules in your mind. So I cannot cancel them out right now because there's a plus sign. Okay, so don't try to cancel stuff out as it's written. But because there's a plus sign, that means it could have been 2 separate fractions before, right? So what I can do is I can undo the addition. I can separate it into 2 separate fractions, and then I would be able to cancel some things out. That's one approach. I also could start by trying to rewrite on the other side secant and cosecant as sine and cosine, and that would end up working out too. All right, so there's 2 ways you can start this. You can try to simplify the left-hand side, or you can try to rewrite the right-hand side, and both will get you to the right answer. So you need to know that there are multiple approaches to both of these, or any of these. There's not just one right answer. Maybe the way that I show you isn't the way you would have done it, and that's okay. All right? So I'm going to split this left-hand side into 2 fractions. Now that it's separated, now I can start canceling things out because you have something divided by something. There's not anything being added in the middle. So I can cancel out this sine theta and cancel out this cosine theta. So I'm trying to show that the left-hand side is equal to the right-hand side. So I want secant and cosecant. Or I could rewrite the right-hand side to match this side, whichever way you want to go about it. But if I have something over cosine, right, that's the same thing as secant. If I have something over sine, it's the same thing as cosecant. So it's like having 7 times 1 over cosine. Right? So I have 7 secant theta. Same thing for sine. It's like 5 times 1 over sine. So I have 5 cosecant theta, which is what I wanted to begin with. So I've shown that both sides are equal to each other. But questions about what I did? Any questions? All right. On this next one, we have this complicated fraction with some addition. We're trying to show that cosecant squared minus cotangent squared. Again, it depends on what side you want to start on. I'd probably start with the fraction side. If you're looking and you have sine and cosecant and cosine and secant, what do you know about sine and cosecant and cosine and secant? Sine and cosecant are reciprocals of each other, and so are cosine and secant, right? So if I rewrite cosecant and secant, then I'm probably going to be able to get some things to work out for me. So cosecant is also 1 over sine. So I'm just rewriting that fraction because I know they're reciprocals. So when you're dividing fractions, what are you really doing? Multiplying by the reciprocal, so I have sine A times sine A over 1 plus cosine A times cosine A over 1. So what's sine times sine? Sine squared. And cosine times cosine is cosine squared. And hopefully you know what this equals. So what is sine squared plus cosine squared? 1. It's one of those identities. Sine squared plus cosine squared equals 1. There's nothing else I can do to that, right? I have 1. Like, well, I mean, it's 1. Okay, so I mean, I'm at a stopping point. So now if you look to the other side, right, so on this one, I might need to look at both sides. I have cosecant squared minus cotangent squared. Again, if you're trying to learn those identities, there's an identity that has cosecant squared and cotangent squared in it. And it says cotangent squared plus 1 equals cosecant squared. All right? I need to rewrite that so that I have hopefully cosecant minus cotangent. Well, it says 1 equals cosecant squared minus cotangent squared. So cosecant minus cotangent squared also equals 1. So I've shown that both sides are equal to each other. Questions on any of those steps I just did? Every one of you should be able to do this next one. So I want you to try that on your own. Like a learning target 3, like baby example. You guys can totally do this one, promise. So go ahead and do it, and I'll make sure to get the answer in a second. Try it out. Okay. On this one, if you're trying to figure it out, you're looking at the right-hand side, there's a fraction, and you'd like for there to be functions that would cancel out somehow. So cotangent can be rewritten that has a cosine and a sine in it, and cosecant can be written as 1 over sine. So that's what you would do. You'd have cosine x over sine x divided by 1 over sine x, just rewriting those two functions. Then you would multiply by the reciprocal, so you have cosine over sine x times sine x over 1. And the sine x is canceled out, and you're left with cosine, which is what you wanted on the left-hand side. You did something like that in learning target 3. Okay, on the next one. You have 1 over tangent x plus secant x, and you have cosine x over sine x plus 1. If you have cosine x and sine x in part of the identity, then you probably want the other part to have cosine x and sine x in it. Okay? So, I'm going to work with the left-hand side. How can I rewrite tangent and secant so we have cosine x and sine x involved? How can I rewrite tangent? Yeah, so I have sine x over cosine x. And how can I rewrite secant? One over cosine. So then just in the denominator, I have two fractions I can add together because they already have a common denominator. Right? So I have sine x plus 1 over cosine. That's looking very close to what we have on the right-hand side. If you're dividing fractions, again, you multiply by the reciprocal, right? So we're going to have 1 times cosine x over sine x plus 1. If you have 1 times something, it's just itself. So we just get cosine x equals sine x plus, cosine x over sine x plus 1, which is what we wanted on the other side. So that one's just a matter of rewriting the pieces and then doing some algebra steps. Yes. So sometimes it'll work. So some are easier than others. So sometimes just subbing identities, like small ones in for the other ones, will work out and I'll pan out. Sometimes it won't. Like on the next one, it won't, and I'll explain why. So we have to do some more things that are more complicated. That's why I'm showing you all these examples so you can see there's different things that could happen. And maybe there's multiple ways to start one, or maybe there's just one way. But so on the homework, there'll be some that are easier than others. All right, some you'll be like, oh, okay, this works out, and some that maybe you need to ask me about, that kind of thing. That's why on the quiz, I have them separated kind of into level of difficulty, because like 3-point questions are going to be like this first one that you guys did. That one shouldn't be so bad, right? But then ones that involve like factoring or maybe doing some extra steps that are weird would be like 4 points. And then the next one we're going to do would be a 5-point question because it's way more complicated. Okay? So I've got it separated on the quiz by difficulty, so you're not forced to do a bunch of crazy hard questions. Okay? Any other questions about the example I just did? All right. Now on this one, I've got cosecant theta minus cotangent theta equals 1 over cosecant theta plus cotangent theta. So here's the problem. If you try to rewrite this with sine and cosine and everything, you're still going to have the same issue that I have right now. On one side, you have both functions being subtracted. On the other side, I have 1 over both the functions being added. Right? If you rewrite them, you still have the same issue. You have 2 things being subtracted and 2 things then being added. Right? So that's not going to work. In this example, I don't think I would expect you guys to know what to do. That's why I'm showing it to you. All right? So we're going to use the idea of a conjugate that you learned about in algebra. All right? Cotangent theta. So I need to be able to do that on the other side somehow. By using a conjugate, then I should be able to accomplish that. So here's what we have. By doing so, you get exactly what you want on the left-hand side in the numerator of this fraction. Right, that's what I'm trying to achieve, is what I just wrote down. Right, that's 1 times cosecant theta minus cotangent theta. That's what I want. In the denominator, you would need to FOIL, but by using a conjugate, the whole point is that when you FOIL, that the middle terms drop out. Right, that's the whole point of a conjugate. When you have the opposite signs, all that stuff in the middle goes away. So I'd have cosecant theta times cosecant theta, which is cosecant squared theta. Then I would have a cosecant cotangent that's negative, and then a cosecant cotangent that's positive that would cancel out. And then I have cotangent times negative cotangent, which is negative cotangent squared. Just FOILing, like we did in algebra. But the middle terms go away. That's the whole point of using a conjugate. So all those things you learned about in algebra and algebra 2, we're using those ideas. So sidebar, I'm going to leave this page for about 15 seconds. In the last problem, we showed, like on the last slide, we had cosecant squared minus cotangent squared was 1. Right? We have the exact same thing here. We have cosecant squared minus cotangent squared. So cosecant squared minus cotangent squared is just 1. Which is just cosecant theta minus cotangent theta, which is what we wanted from the beginning. Would I have expected to do that on your own? Probably not. That's why I'm showing you different types of examples today in class. Okay. 2 more. On the next one, you can start on whatever side you want to. So would you rather start on the left-hand side or the right-hand side? We're going to do both. So I heard Alyssa say right. So I have a sine over here. We know that tangent can be rewritten. We know secant. I've got a cosine over here. So we know secant can be rewritten. So I'm probably going to try to get everything in terms of sine and cosine because I already have a sine and cosine in the problem. Okay? So how can I rewrite secant? 1 over cosine. If I wanted to subtract these, what needs to happen? If we want to subtract these two, what has to happen? Common denominator, right? So I need to multiply the second fraction by cosine over cosine because I need a common denominator. So when you multiply that, you get cosine squared over cosine. But now at least I have a common denominator. So now I can put that into one fraction. 1 minus cosine squared over cosine. What identity do we know about that's a 1 and a cosine squared in it? Sine squared plus cosine squared equals 1. So if I rewrite this, I have sine squared equals 1 minus cosine squared, right? So that numerator can also be written as sine squared. Because 1 minus cosine squared is equal to sine squared. There's two ways about going about doing this now. We can go back and work with the left-hand side and get it to match this. Or we can keep working with the right-hand side to go back and make it match the left-hand side. So I'll do both. Okay? Let's go back to the left-hand side. How can I rewrite the left-hand side? What can I rewrite in the left-hand side? Yeah, tangent is sine over cosine. So those are being multiplied together. Ethan said it was sine squared over cosine squared. Sorry, over cosine. Which is what we wanted. That's what we have down here, right? So we've now shown both sides are equal to each other. You could have also, instead of working with the left-hand side, down here, you can split apart the sine squared. And one of those makes a tangent. So you have sine times tangent, which is what you want on the left-hand side, right? So maybe you work with both sides, maybe you're with one side, whatever you feel comfortable with. Okay? You have to show that both sides are equivalent. I think most of you guys probably would have gone for this method, and that's fine. Okay. Mm-hmm. Oh, did you get a common denominator? Up at the top? Yes. Other questions before I move on? All right, on the last one. Anytime you ever see a binomial squared on these problems, you need to FOIL. If you don't FOIL, you're going to be missing out on probably important information that's hidden because you didn't FOIL. So if we're going to FOIL, we have sine times sine, which is sine squared. We have sine times negative cosine. So that's negative sine times cosine. Negative cosine times sine. And then negative cosine times negative cosine is positive cosine squared. Right, all I did was FOIL. What do I know about sine squared plus cosine squared? That equals 1. And then I have negative sine cosine and negative sine cosine. So that's pretty much two of the same terms. So I have minus 2 sine A cosine A. Everyone okay with what I just did? Right, sine squared plus cosine squared is 1, and I just combine the two middle terms. Just like if I had an x and an x, right? Okay, I can't really do anything else on that side, right? I mean, I'm kind of stuck. I'm at a stopping point. So we look at the other side. And it says 1 minus 2 sine squared A cotangent A. So what probably needs to happen on this side? Probably need to change the cotangent part. What can I change cotangent into? Cosine over sine. If I do that, then what can I get rid of? I can get one of the sine A's. I can cancel out, right, because I have sine squared. So now I have 1 minus 2 sine A times cosine A, which is what I had on the other side. So I understand these are difficult, and they're all a little bit different. This is, out of all the learning targets we do all year long, this is the hardest one. The rest of the ones we do, learning target like 5, 6, 7, and 8, those leave us at a starting point. Right? There's a formula you have to use, so at least there's a starting point. Here, there's not really a starting point. It's like you have to kind of like look into it and try to think about what might happen. Okay? So that's why I'm giving you time in class. You have the rest of class today to work on some. You have all class period tomorrow. You have all class period the next day. All right, so I'm not checking Learning Target 4 homework anytime soon. I want you to work on it. But that means I want you to work on it and ask questions and not try to like copy down my answers, because then you won't know how to do it. Right? Does that make sense? All right. Thank you for being a good listener.